Jai Hind viewers, I am Sudhakar Dwivedi, Assistant Professor in Information Technology Department. And today we will discuss a very important topic in the object-oriented programming, that is the collections framework. So in today's lecture, we will look what is actually the collection, what is the collections, and what is the advantage and disadvantages of these collections framework, and why we need to use these types of the collection frameworks in Java. So in this unit, we will look for the collections in the Java. What is the collection framework actually means, the whole hierarchy of the collection framework, what is the iterator interface, what is the collection interface, and all the implementation classes related to these collection interfaces. And we will also look about the comparator and comparable interface in this unit, and including the properties class in the Java. So one by one we will discuss. First of all, what is the framework actually? So what frameworks facilitates us? So if we am talking about the frameworks, that means the ready-made code or the ready-made architecture, or the architecture where we can just use the codes for our application development. So it's facilitate us with the various tools and techniques so that we can easily implement or we can easily build our applications. So it represents a set of the classes and interfaces. It is optional, but if we use the framework, we can just expedite our application development process. So we will look what is the collection framework. So before we will discuss about the collections framework, we need to understand what really collection means. So what is the collection actually? So we can just define the collection as an the container of the objects, or we can say the collection is just like a single objects which can act as the container of the multiple elements to store in this container. So we can just define a collection or the collection. This collection is like the single object is acting as a single object, and it can act as the container for storing the elements of the different types of the elements. That means can store the different types of the objects into it. But in the collection, we are not going to store the actual physical copies of the objects. We are only stores the references of the objects. So collection means the collections of the objects, we can say, but it is not actually going to store the actual physical copies of the objects. It only stores the references of the multiple objects. That's why I am saying it is act as an object. The collection is act as a single object that stores the multiple elements into it. So collection in Java is a framework that provides an architecture to store and manipulate the group of objects, if we can say. So if we want to manipulate or we want to perform some operations on the group of the objects, we can use these type of the collection frameworks. Java collections can achieve all these operations that we perform on the data, like searching, sorting, insertion, deletion, all these types of the operations that we need to perform regularly on the data structures. All these operations are easily provided by these collection framework. So what is the collections in the Java? So we have discussed the collection framework. The collections frameworks provide all the collections interfaces and the classes, methods to facilitate the operations on the collection objects. So what is the collections? So these are the two different terms. One is the collection and another one is the collections. And third term, we are talking about the collections framework. So the collection framework is the whole hierarchy of the classes and interfaces that will support the implementation of these data structures. And in this collection framework, the collection is an topmost or the root interface. All the interfaces are just extended from these interfaces. That means all the implementation classes are available in the sub interfaces of this collection interface. So we am talking about the collection framework. So the collection framework have a lot of interfaces, and in this interfaces, the collection interface is the root interface. So the collection, if we am talking about the collection singular word, and the collection is the topmost interface in the collection framework, and the collections is the class in the Java. So the collections is a class and the collection is the interface. So collections class have a lot of the utility methods that we regularly use, like the sort method, min method, or the max method. So the collections is actually a class, or basically it's a utility class in the package java.util package, and this just support the operations that we regularly perform. All the methods in the collections are static that we can directly call, and it has a different methods for the different operations, as we have mentioned that, like if we want to sort the collections, we can use the sort method. If we want to find out the minimum value in the collection, we can use the min, and if we want to find out the maximum value in the collection, we can use the max method. So all these utility methods is defined in the collections class. So there are two terms that is frequently used. One is the collection and another one is the collections. So as I have told you, the collection is the root interface in the collection framework, and the collections is a class that provides the utility methods. So what is the difference? How can differentiate the collection and the collections class? That means the collection interface and the collection class. So what I have said, the interface in the Java collection, this is an interface in the Java collection framework, and it is the root interface, and this is the utility class. So the collection is the interface, and the collections is a class, is the utility class. What is the purpose of using the this interface? It just represents a group of elements or group of objects. Collections means it's a group of objects, and it provides the utility methods for our regular operations. What is the use of this collection interface? So that we can implement the different types of the operations by using the different set of the interfaces or the classes. And if we want to operate some, if we want to perform some regular operations, we can use the utility methods. So these are the some classes, like the array list has said, that will implement the collection interface. And if we want to use like the sort method, we can directly call it with the collection class here. So the collection is the class because it's a static method. So we can directly call this method from the collection class. So what is the actual need of these collections in the Java? Why we actually require the collections in the Java? So if we want to store the multiple objects into the single unit, what was the how we can store it? So there are various methods through which we can store the multiple objects or the multiple elements. The one way is to store the multiple elements into the multiple variable. That is very complex. And another way, we can create an array, and under this array we can store the multiple elements. But the disadvantage of these methods is, in the first one, we have to create the multiple variables. That is very tedious or very complex process. And in the second one, where we are going to create the array for storing the multiple elements. But the only limitation is that the array is not in the growing nature. The array is the static. That means if we are not able to decide the size of the array, so we may not fulfill our application developments or storing of our data. And the disadvantage is that we can only store the similar type of data elements. So in the future, if we want to store more elements, we cannot perform these types of the requirements in the array, because the array is not in the growable nature. So these are the limitations, and these are the limitations can be overcome by this concept, like the collections, that will store the multiple elements into the single container, like the collection object, that can store the multiple types of the objects, multiple type of the values. Maybe sometimes it is the duplicate values, maybe some types of the unique values, and maybe sometimes of the different types of the data elements we can store it. That is what not possible in the array. So what is the basic use or what the basic requirement of this collection in the Java? So it provides the various data structures and algorithms that we can use for storing the different types of the data elements, so that the operations can be easily performed on it. And what was the main disadvantage that I have discussed? Apart from these disadvantages, if we were using the array and we wanted to perform some operations on the array, all the operations we need to write manually, and that may or may not be optimized for that operations. But this collection framework provide not only the way of storing the different type of the data element in this collections, but it also provides the different set of the operations that is already optimized. That means we are not we did not bothered about the optimization of these types of the algorithms. That means algorithms that are written in this type of the framework, it is already optimized for all types of the operations. So there are two main advantages if I am talking about these collections in the Java. So the first one is we do not have to write the code to implement these data structures. That means whatever the data structure is defined in this collection framework, we do not need to bother about writing the algorithms manually. And not only we are freed from writing these types of the algorithms manually, it is also optimized for the higher performances. So our code will be much more efficient than we will regularly write. So our code will be more efficient as the collections in the collections, because in the collections framework it is highly optimized. So all the algorithm that is written for the operations, it is highly optimized for the operations. And moreover, the collection framework allows us to use the specific data structure for the particular type of the data. That means if we have some set of the operations, so to perform some set of the operations or some specific type of the operations, we have a different types of the data structures that we can use in the collection framework. So we can see these the list of the requirements or the list of the areas where we can use this type of the collections. Like I have just discussed that array have the fixed size, it is not the growable size, and if we need to grow our data requirements in the future, the array will not fulfill it. So because the arrays will not support the array is not supporting the dynamic resizing, but the collections is supporting the dynamic resizing here. So the main advantage of this collection, it is the dynamic resizing. We can resize our memory requirements according to our need. It provides a ready-made data structures. I have said it have a lot of the ready-made data structures and the methods that is already optimized for the operations. So it have a lot of ready-made data structures like the list, set, and map for the different set of the requirements, and it offers a lot of built-in algorithms via the collections classes, and all the operations, all the algorithms that is written, it is efficient, it is optimized for their performance. So performances is already efficient. So we do not need to bother about to write an efficient algorithms. And it also ensures always the code reusability and all the standardizations. And most of it supports the type safety and generics. So we do not bother about the type safety and the type casting at every steps. It handles all the types of the generics, and we do not need to write it manually. So the collection framework, if we are summarize it, the collection framework just reduces the development time and the burden of the designing of the algorithms and the different set of the methods. So the programmer's overhead of designing these set of the optimized algorithm is just minimized, and we can write the code in the less number of the lines and the optimized code one. So the code is easier to maintain because it provides the useful data structures and interfaces that reduce the programming efforts of the developer. And I have just mentioned this container, this collection in the collection framework that I am talking about. This is the collection, and this collection container is the growable in the nature. That means it will just use the memory requirement that we require at that particular of the time. And it implements the high performance of useful data structures. That means all the operations in this type of data structure is highly optimized, an algorithm that increases the performances at all times. And I have mentioned also it always uses the software reusability. That means all the components that are designed in this framework can be reusable. So all these classes and interfaces that we will use in this collection framework are all defined in this package, java.util package, that contains all the classes and interfaces for these type of the collection framework. So if we look the collection framework largely, so it have this is the collection interface, then map interface and iterator interface. So these types of the interfaces we will use. So I have separated the map interface and iterator interface from the collection one. The collection interface have only these types of the interfaces and some of the implementation classes that we will discuss in the subsequent lectures. But if we see in this type of the collection, the root interface is the collection, and this is the various sub interfaces from which that can be implemented from the various set of the classes. This is the map interface and the iterator interface. This is the collection framework. So if we talking about the whole hierarchy of this collection framework, so we can see here. So this is the collection, and the root interface is the collection, and this collection, I'm talking about the collection. If we see there is a top element, this is the top interface is the triple. But if I'm talking about the collection interface only, so we can just say that the root interface is the collection one, and from which all these types of the interfaces are derived. So if we want to create a list, or if we want to create a queue or the set data structures, we have the different sets of the implementation classes by which we can implement the list. That means if we want to create the list in some time, we can use these set of the classes like the array list, linked list, vector, or stack to just implement this list interface. So we can create the list by the array list or linked list or the vector. If we want to create a queue, so we have the queue, and DQ is derived from the queue. We can create the priority queue. This is the priority queue class, and from the priority queue class, just implement the queue interface. The array DQ class directly implement the DQ interface. We have a set interface. This is the different purposes of these types of the interfaces that we will discuss in the subsequent lectures. So this is the set interface. Sorted set is just derived from the set interface. So hash set and linked hash set classes can directly implement the set interface, and the tree set, this is the class that can directly implement the shorted set interface, this one. So this is the whole hierarchy of the collection framework. So as I have discussed, there is a different types of the interfaces like the list, queue, and the set. So what is the basic requirement of these types of the interfaces? What type of the values we are going to store? Why we are differentiating all these types of the interfaces? So let's discuss one by one. So when we use the list interface actually, so the list interface we will use when we have to store the elements in the ordered collection. That means it is provide the facility for the ordered collection of the elements. So we can just say that the list interface is an ordered collection that allows us to add and remove elements like an array. So as an array, we were performing the insertion of elements or the deletion of elements in a particular order. We can do that in the list interface. The set interface. So the set interface is used to store the elements in the different sets similar to the sets like in the mathematics. And what the property of the set? It will not allow the duplicate elements. It cannot have the duplicate elements. In the list interface, it is possible to store the duplicate elements, but in the set interface, the duplicate elements is not allowed. That means if we want to store the distinct element and we have to perform some set operations like in the mathematics, we will use the set interface. Otherwise, we can store the list interface if we want to ordered collection of the elements, or we just want to insert and delete the elements like an array. So the queue interface. What is the queue interface? So the queue interface is used when we want to store or the access element in a particular manner, like the first in and first out. That means the element that is first inserted, that is first come, may be served the first. So in the queue, the element that is added earlier will be processed first. So this is the first in, first out manner. If we want to process some of the data, we will use the queue interface. So here is a processing of the data in a particular manner. If we want to process the data in a particular manner, we will use the queue interface. But in the list interface, we can, if we use the list interface and we want to we want to implement the list interface by the array list classes, we can add the data anywhere we want. We can remove the data from any locations. But in the queue interface, there is a compulsion. The data that is earlier inserted can be deleted the first. When we will use the map interface, so the map interface we will use when we want to store the data in the form of the key and the values. So it will support to store the values in the form of the keys and values. Another one is the iterator interface. If we want to access or if we want to just traverse all the elements of the collection, we will use the iterator interface. So the iterator interface just provides the methods that can be used to access the elements of the collection that we want to traverse all the elements of the collection. We can use the iterator interface. It's the iterable interface. I have just mentioned iterator interface. So iterator interface, it just provides the methods to just iterate the collections. That means just traverse the collection. And it is the iterable interface. So iterable interface that I have shown you. This is the top level of the interface in the collection framework. And the iterator interface is the interface that will provide some methods to just iterate the collections. So what is the iterable interface? So iterable interface is the root interface for all the collection classes, And the collection interface extends these type of the iterable interface. So it contains some of the methods like this iterator method. So this iterable interface have this method, iterator method, and it returns the iterator over the elements. So as I have mentioned, what is the collection interface? So collection interface was the root interface of the collection framework hierarchy. I am talking about the collection framework hierarchy. And all the collection classes, root element was the iterable interface. So Java does not provide the direct implementation of these collection interfaces. Java does not provide the implementation of these types of the interfaces, but it can be implemented by its sub-interfaces. Like the collection interface, this is the root interface, but Java doesn't have any mechanisms to directly implement this type of interface, but it can be implemented by these type of the sub-interfaces. We have a different type of the sub-interfaces that can be utilized to implement this type of the interfaces. So we have the list, set, and queue interfaces. The sorted set interface is just derived from the set one, and the DQ interface is just derived from the Q1. So these are the methods that are available in the collection interfaces. So like the add element, if we want to add some element to the collection, we can use this add method to insert an element into the collection. Add all. So there is a basic difference, add and add all. That means if we want to add a single element, we will use the add method. And if we want to add the whole collection to another collection, we will use the add all. So here we have mentioned a single object, and here we have mentioned a whole collection. That means if we want to add one collection to another collection, we will use the add all. That means add all the elements. To insert another collection in the present collection, then we will use the add all methods. Similarly, we have a remove and remove all methods. If we want to just remove the one element, we will use the remove method. And if we want to remove all the collections, that means if we want to remove another collection from the present collection, then we will use the remove all. Subsequently, we have a different methods we have mentioned in this. Like if we want to check whether the collection is empty or not, it provides the true or false. That means there is empty methods. It will return a Boolean value. If we want to just check whether our collection is empty or not, we can use the is empty methods. If we want to check if the two collections are the same or the different, we can use this equal methods. If we just used this is the contains method, it is just for searching purposes. That means if the elements of the another collection are present in the collection or not, if we want to find out it, if we want to track out of such type of things, that if the one collection is present in another collection or not, we can use the contains. That means this type of the collection is contained in another collection or not. So these are the different types of the methods. So we will just look the implementation of the specific type of the interfaces. So I have said the list interface is the child interface of the collection interface, and it's a list type data structures where we can store the ordered collection of the elements, and it can have the duplicate elements also. As I have mentioned earlier, that the set interface was not allowed to store the duplicate elements, but in the list interface, it can have the duplicate elements. So list interface is implemented by these types of the classes: array list, linked list, stack, and vector. So these types of the classes through which we can just implement this type of the list interface. So if we want to implement this type of the list interface, just we can see. So we can implement this list interface by the array list. That means we can create the object of this type of array list, or linked list, or vector, or stack. So this list interfaces can be implemented by these types of the classes. So array list class implements the list interface, as I have said. If this list interface can be implemented by the array list class. And what is the difference between the array and the array list? Array list is the dynamic array to store the duplicate elements of different data types. The array list class maintains the insertion order, and here there is a need to mention that it is not the synchronized for the operations that we will study in our subsequent lectures. The element stored in the array list class can be randomly accessed. That means if we want to access the elements in the random order, we can use this type of the array list. So here is a one program that we can implement. So we can see here we have created one of the array list, one of the container. So this is array list I have created by using the array list class here. I have just used the array list class, and we have created and collection. And now we want to add the elements to the array list. I have just used the for loop, and in this collection object we are just calling the add method subsequently. If we want to remove the elements, then we can use the remove method on this particular collection. If we want to just display all the elements, so just we can use the loop, and we can just use the get element to find out and display all the elements. Thank you so much for today's class. We will discuss the different mechanisms for the implementation of this list interface. Thank you so much.